Prashant sir, Amol sir, we are live now.
नमस्कार अमोल सर, नमस्कार सर,
आपण
अभिनव सर.
सुरू करायला हरकत आहे.
Okay.
हा, sir.
Okay, can I start, sir?
सुरू करून द्या, sir. काय problem?
Okay, can I start?
Yes, yes,
Yeah. Am I clear, audible, and
yes, yes,
visible?
yes, yes,
Okay. Amol sir, can I start?
yes, sir.
Okay. So, good morning to. Okay. Can I start now, sir? Am I clear, audible, and I'm start. Amol sir. Amol sir.
Yes, sir. Yes, sir.
Okay. Thank you. Thank you, sir.
Yes, sir. Prashant sir, you are audible and visible.
Yeah, I'm really thankful to you, sir. Thank you, Abhinav, sir. Good morning to one and all, student of Maharashtra. I'm Professor Prashant Patel, along with me, colleague, and my co-host, Professor Amol Jadhav, sir, from Deccan Education Society, Kirtiyam Dungarsi College, Dadar West, Mumbai. Welcome you all for the virtual classroom of science stream for subject physics. I hope you all doing well during pandemic situation of COVID-19. I hope you also taking all precautions and preventing measures for keeping good health. I would like to tell thanks Government of Maharashtra, Education Department, SCRT technical team, SCRT for providing us such technical and online platform. I equally thanks and grateful to our parental institute, Deccan Education Society, and Kirtiyam Dungarsi College, principal and higher authorities, to give one chance to deliver such online lectures. My dears, this is the second lecture of mathematical method physics. Second number chapter, mathematical method of physics, part 1. So let me share my screen first and then we'll discuss more. Okay, dear, this is the second lecture of this mathematical method. Here, in that mathematical method, we already learned many terms. In this mathematical method, we study at here about first its introduction, vector analysis, and we also take some part of vector operations. Okay, what is vector analysis? What in that vector analysis, which we learned already in last time? ये वेक्टर एनालिसिस में हमने क्या स्टडी किया है, उसमें हमने कौन से टर्म्स देखे हुए हैं, हम जरा देखते हैं और आगे निकलने की कोशिश करते हैं. So in that vector analysis, first we study at here about scalar. We know scalar. Scalar is a physical quantity which are completely described by magnitude. Which are completely described by magnitude. Magnitude is nothing but the number and unit. If we take example of length, suppose if you take a metal rod and if we have find out its length, or if we measure length, if it's suppose 2 meters, so here 2 is a number and meter is a unit. So the length of this metal rod is completely described by this magnitude 2 meter. Hence, length is a scalar quantity. In such manner, we are taking number of quantities: length, mass, time, temperature, area, volume. This scalar can be added or subtracted by simple rule of algebra. We know that. As well as in last lecture, we study about this vectors. What is vectors? A quantity which need magnitude and direction for its complete description. Oh, magnitude and direction. There is also direction. There is a direction. So vectors required magnitude and direction for its complete description. If we take examples, displacement, velocity, linear momentum, acceleration, force. Here this vector can be added or subtracted by vector algebra, vector law of addition. In vectors, we are not use a simple law of algebra. We are use here vector algebra. Now in last lecture, we take also difference between scalar and vector. Scalar has magnitude only. Vector has magnitude as well as direction. Scalar can be added or subtracted according to the rule of algebra, simple algebra. Why? Because in scalar, we are thinking only magnitude. In vectors, vectors are added or subtracted by vector algebra. Here we are use vector law of addition or subtraction. Here we are not use simple rule of algebra. Scalar has no specific representation. Why? Because it's only magnitude. Vectors represented by symbol, just like an arrow. Then we are take at here definitions. Then we are take at here examples. हमने उसके बाद में यहाँ पे examples लिए थे. Okay? Then we can show that a graphical representation of vector also. How we can represent this vector? So vector can be represented by direct line segment or an arrow. Suppose if you take example of displacement from P to Q. So P is the end point, which is the tail of this vector. Q is the end point, which is the head of this vector. We can show at here vector PQ. This vector we can also represent by single capital letter, just like vector X, where X is nothing but the magnitude and this above arrow shows its direction. After then we take some definitions, just like zero vector having magnitude 0, but it's having particular direction. Then we take at here equal vector definition. Yet these two vectors are equal. When? If these two vectors having same physical quantity and these two vectors having same magnitude and direction, then we can tell equal vector. Then हमने next definition study किया था negative vector के बारे में. What is negative vector? Negative vector of a given vector of the same magnitude but opposite in direction of that given vector. यहाँ पे वेक्टर P जो दिया है उसके एग्जैक्ट अपोजिट में वेक्टर Q है, बट उसकी डायरेक्शन अपोजिट में है, इसलिए वेक्टर Q को हम कहेंगे नेगेटिव वेक्टर ऑफ वेक्टर P. देन हमने नेक्स्ट डेफिनेशन स्टडी किया था रिजल्टेंट वेक्टर के बारे में. रिजल्टेंट वेक्टर व्हिच इज नथिंग बट द रिजल्ट ऑफ टू और मोर वेक्टर्स. एक्चुअली रिजल्टेंट वेक्टर एक सिंगल वेक्टर होता है जो रिजल्ट होता है दो या तो दो से ज्यादा वेक्टर्स का, जो क्या प्रोड्यूस करता है, सेम इफेक्ट प्रोड्यूस करता है जो अदर्स वेक्टर्स ने मिलके किया होगा. द रिजल्टेंट ऑफ टू और मोर वेक्टर इज अ सिंगल वेक्टर which produce the same effect as produced by all the vectors together. Okay, so in last lecture we also study about unit vector. Never forget this definition of unit vector. Unit vector is very important article for us. What do we learn in that unit vector? A vector having unit magnitude. Unit magnitude means there is one magnitude. But yes, this unit vector having direction. Which is its direction? Its direction is the same as the given vector's direction. जो भी वेक्टर आपको दिया होगा उस वेक्टर के डायरेक्शन में इस यूनिट वेक्टर की डायरेक्शन होती है, बट इस यूनिट वेक्टर का मैग्नीट्यूड यूनिट होता है, 1 होता है. If we take example of vector A having magnitude is A, and its direction if you want to show, then this direction of vector A we can show by unit vector. So unit vector का बेनिफिट क्या था? बेनिफिट यूनिट वेक्टर का ये था कि हम यूनिट वेक्टर यूज करके मैग्नीट्यूड एंड इट्स डायरेक्शन को हम सेपरेट कर सकते हैं. सो वी कैन राइट एट ए वेक्टर A is equal to A into u cap, where u cap is nothing but the unit vector. So we can write at u cap is equal to vector A upon A. Okay, along x axis अगर मैं लेता हूं तो वहां पे यूनिट वेक्टर I होता है. So vector x upon x. Along y axis we take unit vector j, vector y upon y. Along z axis unit vector is k, which is nothing but the vector z upon z. ओके, यहां तक हमने वेक्टर एनालिसिस के बारे में स्टडी किया था. देन हमने वेक्टर ऑपरेशंस के बारे में अगर हमें स्टडी करना है तो एडिशन एंड सब्सट्रैक्शन के बारे में हमने स्टडी किया था. इफ यू टेक टू वेक्टर both having same direction means they are parallel, then they are added. If they same direction or parallel, then they are added. If they are in anti-parallel means in opposite direction, then they are subtracted. If they parallel same direction, they added. If they parallel, anti-parallel and opposite direction, they subtracted. Okay, but अगर suppose ऐसे में दो वेक्टर लेता हूं जो ना तो एक दूसरे को पैरेलल हो ना तो एंटी पैरेलल हो, मतलब उनकी कोई डायरेक्शन फिक्स नहीं होगी, तो क्या हम उसको ऐड कर सकते हैं? तो क्या हम उसको सब्सट्रैक्ट कर सकते हैं? Yes, we can add or subtract by using triangle of vector addition, which we learn in last lecture. हमने triangle of vector addition में क्या स्टडी किया था? Here we are take two vectors of same type. It means suppose first vector force का है तो second vector भी force का होगा. Okay, there are these two vectors, vector A and vector B. Represented magnitude and direction, दोनों vector को magnitude भी है as well as direction भी है. and these two vectors are taken to adjacent side of the triangle. अब यहां पे जो ट्राइंगल के ये जो दो वेक्टर है, ये दो वेक्टर के हमने दो साइड लिए हैं, बट लेते समय हमें कैसे लेना है? टेकन इन ऑर्डर. टेकन इन ऑर्डर मींस जहां पे फर्स्ट वेक्टर कंप्लीट होता है वहां पे सेकंड वेक्टर स्टार्ट होता है. ओके, टेकन इन ऑर्डर मतलब हेड ऑफ फर्स्ट वेक्टर, सो दे स्टार्ट, टेल ऑफ सेकंड वेक्टर. सो टेकन इन ऑर्डर, जहां पे फर्स्ट कंप्लीट होता है वहां पे सेकंड स्टार्ट होता है. So then the resultant vector is represented by magnitude and direction. तो obviously ये दो वेक्टर का हमें resultant vector मिलेगा जिसको magnitude भी होगा as well as direction भी होगा. But ये resultant vector कौन सा होगा? Third side of the triangle. जो third side of triangle हमने denote किया है रेड लाइन से, देखो यहाँ पे triangle के डायरेक्शन डायग्राम में. अब ये जो triangle का थर्ड साइड होगा उसे हम कहेंगे resultant vector, जो स्टार्ट होगा starting point of the first vector. And कहां पे end होगा resultant vector? Ending point of the second vector. This is the resultant vector which we are drawn in the opposite sense. I say opposite sense. Opposite sense means here starting from the first vector and end at the second vector. So this is the vector addition by using triangle law. Now using this triangle law, we can show vector addition is commutative. Vector p plus vector q is equal to vector q plus vector p. Here we can show by using this triangle law. Now using triangle law, we can also show vector addition is associative. How? We already learned in last lecture. So my dears, in last lecture we already studied scalar, vectors, their difference, some definitions, and most important law, which is the triangle law of vector addition. Okay, here these two vectors taken in order in triangle law. Okay, so this is the triangle law. Now today we want to learn at a most important law, which is nothing but the law of parallelogram of vectors. My dears, this law parallelogram of vectors is very important because on this article there is one also practical. इस आर्टिकल पे वहां पे एक प्रैक्टिकल भी है. तो let's try to learn this law parallelogram. So on your board exam or in CET, in JEE, in NEET exam, there is some numerical are also asking on this topic. So we'll study with concentrate law parallelogram of vectors. Okay, if two vectors of the same type, we take out here two vectors and these two vectors having same type, means if first vector having if the first vector force, second vector is also force. Here we take two vectors. Here we take two vectors. Suppose I'm taking first vector is vector p, OA. This is the first vector. Now there is also second vector, which is nothing but the vector q. This is two vectors, vector p and vector q. These two vectors of the same type, originating from the same point. Originating from the same point. Look at here. Vector p start from O and vector q start from O. Both originate from the same point. Means here tail to tail. देखो बच्चों यहाँ पे डिफरेंस है. किसके बीच में डिफरेंस है? ट्रायंगल लॉ एंड पैरेललोग्राम में. ट्रायंगल लॉ में क्या था? जहां पे फर्स्ट वेक्टर एंड होता था वहां पे सेकंड वेक्टर स्टार्ट होता था. दिस इज द ट्रायंगल लॉ. दिस इज द ट्रायंगल लॉ. जहां पे फर्स्ट वेक्टर एंड होता था वहां पे सेकंड वेक्टर स्टार्ट होता था. मींस हेड ऑफ द फर्स्ट, tail of the second. But what happened in parallelogram? If you see carefully in parallelogram, there is a tail of first vector. There also tail of second vector. The starting point is common. Their starting point is same. Tail at the same point. Tail at the same point. This is the difference between triangle and parallelogram. In triangle law, where first vector is complete, the second vector is start. But what happened in parallelogram? In parallelogram, there two vectors start from the same point. Clear? Okay. Look at this statement now. What is statement there? If you say carefully, if two vectors of same type originating from the same point, tail at the same point, are represented in magnitude and direction by the two adjacent sides of a parallelogram. Okay. Here I'm taking vector p represented by magnitude and its direction. Second vector is vector q represented by magnitude and its direction. And these two vectors start from the same point, which is nothing but the tail at the same point. And these two vectors are two adjacent side of parallelogram. Two adjacent side, baju wale hai. Two adjacent side of the parallelogram. I think you know this about parallelogram. What is parallelogram? Their opposite side are equal and parallel. We know. जो भी parallelogram होता है उसमें opposite side कैसे होते हैं? Equal and parallel. So if you see carefully at here, this is nothing but the vector P. Its opposite side is nothing but the BC, which is also vector P. Here is OB is vector Q. Its opposite side is nothing but the AC, which is also vector Q. Okay. So this is parallelogram, and there is a vector P and vector Q is adjacent side of parallelogram. The resultant vector is given in magnitude and direction by the diagonal of the parallelogram. अब ये जो पैरेललोग्राम होगा उसका जो भी डायगोनल होगा, ये डायगोनल होगा उसका रिजल्टेंट वेक्टर. दिस इज वेक्टर आर. दिस डायगोनल OC is nothing but the diagonal. Here the diagonal is nothing but the resultant vector, which are represented by magnitude and its direction. But if you say sincerely here, this diagonal of this parallelogram starting from the same point, जहां पे वेक्टर P एंड वेक्टर Q स्टार्ट हुआ था, वहीं पे ही ये रिजल्टेंट वेक्टर R स्टार्ट हुआ है, starting from the same point. If you see carefully toward this O point is nothing but the starting of vector P, starting of vector Q, and it's also starting of resultant vector R, which is nothing but the diagonal of this parallelogram. So what is the statement of this parallelogram? If two vectors of the same type, originating from the same point, tail at the same point, are represented in magnitude and direction by two adjacent sides of a parallelogram, the resultant vector is given in magnitude and direction by the parallelogram starting from the same point. Here, vector P and vector Q are two vectors which are adjacent side of this parallelogram. Then the resultant vector R, the resultant vector R is nothing but the diagonal of this parallelogram, which is starting from the same point. Okay, if you say carefully here, vector P and vector Q, there is an angle between them is nothing but the theta. Theta is nothing but the angle between vector P and vector Q. Theta is nothing but the angle between vector P and vector Q. Vector P and vector Q are two adjacent sides of this parallelogram, and they are inclined to each other at an angle theta. Okay, now here this resultant vector R, and this is nothing but the law of parallelogram of vectors. Vector P, vector Q are two adjacent sides of this parallelogram. They are inclined with each other at an angle theta. Then the diagonal of this parallelogram is the resultant vector, and which is starting from the same point of these two vectors, this parallelogram. Okay, now this resultant vector R, look at this resultant vector R. This resultant vector R having magnitude as well as a direction. Now we find out at a magnitude and direction of this resultant vector. Now our aim is that, our goal is that, find the magnitude of vector R and direction of vector R. अभी हमें इस वेक्टर का, वेक्टर R का मैग्नीट्यूड एंड डायरेक्शन फाइंड करना है. अगर मुझे वेक्टर R का मैग्नीट्यूड एंड डायरेक्शन फाइंड करना है तो उसके लिए देखो मैं क्या करता हूं. फ्रॉम पॉइंट C, यहाँ पे जो पॉइंट C है वहां से मैं परपेंडिकुलर ड्रॉ करता हूं. आई एम ड्रॉइंग एट ए परपेंडिकुलर ऑन दिस OA लाइन व्हिच मीट एट द D पॉइंट. व्हाट आई एम डूइंग एट हियर, मैंने फ्रॉम पॉइंट C से परपेंडिकुलर ड्रॉ किया है. कहां पे ड्रॉ किया है बच्चों? ऑन OA लाइन पे, जो हमने एक्सटेंड किया है. कहां तक एक्सटेंड किया है? D पॉइंट तक. दिस इज द परपेंडिकुलर. ओके, now we see carefully toward this trigonometry. The angle between vector P and vector Q is nothing but the theta. Then obviously at here this angle is also theta. This is nothing but the angle theta. Okay, the angle between AD and vector Q is nothing but also theta. Using trigonometric, I think you know about that. Okay, now using this we can find out magnitude. How? We'll study afterward, no doubt. And whenever we want to find out direction of this resultant vector R, so that time we find out at here alpha, where alpha is nothing but the angle between vector R and vector P. Vector R makes angle alpha with vector P. Yes, angle के जरिए हम direction find कर सकते हैं. If you know the value of alpha, then we can easily say the direction of resultant vector r with respect to p. अगर हमें अल्फा की वैल्यू पता है तो हम डायरेक्शन बता सकते हैं. किसके डायरेक्शन बता सकते हैं? वेक्टर r की. विथ रिस्पेक्ट टू किससे? वेक्टर p से. Then how we can find out its direction? We like to study about it, no doubt. So our aim is that to find magnitude and direction of this resultant vector. Okay, so see carefully at it. Before starting that, look at the diagram. Look at the triangle OAC. अब जरा triangle OAC की तरफ देखिए. OAC. So if you say carefully, there is nothing but the first vector, vector OA, plus vector AC is nothing but the resultant vector is OC. Using triangle law, vector OC is equal to vector OA plus vector AC. So we can write that here, vector R is equal to vector P plus vector Q. So here, the resultant vector R is equal to vector P plus vector Q. Now, we want to find out magnitude and direction of vector R. Okay, for that, what we are doing? उसके लिए हम क्या कर रहे हैं बच्चों? Simple. उसके लिए हम क्या कर रहे हैं? So we are take perpendicular from point C drawn on this OA line which meet at the point of D. And here the resultant vector R makes angle alpha with this vector P. Okay, so this is the adjustment. Now magnitude of this vector R. Find the magnitude of vector R. Okay, for that we take right angle triangle ODC. I say ODC. Look at the triangle, which is the right angle triangle. Which one? ODC. And we know Pythagoras theorem. Yes. What's Pythagoras theorem yet here? Simple. OC square is equal to OD square plus DC square. Am I right? Using Pythagoras, what I'm saying, using Pythagoras, we can write at here. हम क्या लिख सकते हैं बच्चों? This is the right angle triangle, no doubt. This is the right angle. तो हम क्या लिख सकते हैं? OC square is equal to OD square plus DC square. Okay, then OC square is equal to OD square plus DC square. Now look at here OD. इस OD की तरफ देखिए. OD is nothing but the OA plus AD. Can I write, my dears? Can I write, my dear student? Yes. OD. OD is nothing but the OA plus AD. It's whole square plus DC square. We know A plus B the whole square. हमें पता है रूल कौन सा A plus B whole square का, वो क्या होता है? We can write it here. OA square plus 2OA into AD plus AD square. We know A plus B the whole square. What is A square plus 2AB plus B square? In the same manner, हमने क्या लिखा है? OA square plus 2OA into AD plus AD square plus DC square. Okay, look at here. Look at the triangle ADC. Which one? ADC. It is a right angle triangle. We know Pythagoras theorem. AC square is equal to AD square plus DC square. If you see carefully to this right angle triangle ADC, here AC square is equal to AD square plus DC square. So instead of AD square plus DC square, we are put up there AC square. ये जो AD square है plus DC square है उसके अलावा instead of this, what we can write? We can write at AC square. Now we are put up this in above equation. Then we get OC square is equal to OA square plus 2OA into this AD plus AC square. हमने AC square क्यों लिखा पता चला बच्चों? AD square plus DC square is nothing but the AC square. Okay, now look at here. OC square, OC. We know OC. OC is nothing but the resultant vector. OC is nothing but the resultant vector, vector R. Look at that OA. OA is nothing but the vector P. Okay, OA is nothing but the vector P. We know AC. This is AC. AC is nothing but the vector Q. जो opposite side है, किसकी opposite side है? Vector Q की. OB का opposite AC है. And we know in parallelogram, their opposite side are equal and parallel. So अगर OB vector Q है, तो obviously AC भी क्या होगा? Vector Q. Okay, if you see carefully, we know the value of OC, we know the value of OA, We know the value of AC, but here if you see carefully toward this AD, इस AD के बारे में हमें कुछ सोचना होगा. Okay, look at toward this AD. हमें AD चाहिए. If you see in well manner, this is the angle theta, which is the adjacent side of this angle theta. Adjacent side है. Okay, look at the triangle ADC. अगर मैं वो triangle ले रहा हूं तो ADC, which one triangle? ADC. Okay, we take at a cos theta. You know cos theta? Cos theta? Adjacent side upon hypotenuse. Adjacent side is nothing but the AD, and hypotenuse is nothing but the AC. So you can write at a AD upon AC. AC is on denominator, goes the another side is multiplication. So we can write AD is equal to AC into cos theta. But we know AC. But हमें पता है AC. AC क्या है? Q. So we can write at a AD is equal to Q into cos theta. AD is nothing but the Q into cos theta. Now look at the equation number 1. We know the value of OC. We know the value of OA. We know the value of AC. Now we also know the value of AD. AD की value क्या है? Q into cos theta. Now this all value put in equation first. अगर हमने ये suppose ये सब value equation first में रखा तो हमें क्या मिलेगा? R square is equal to P square plus 2P into Q cos theta. This AD value Q cos theta plus Q square. So if we put up this all values, then we get at here, what do we get at here? R square is equal to P square plus 2PQ into cos theta plus Q square. We can also write this one. R square is equal to P square plus Q square plus 2PQ cos theta. But this is the R square. We want a R. So what do we do? Taking square root on both sides. If we take square root on both sides, then instead of R square, we can write at here R is equal to this all value we are put them in square root, then in square root P square plus Q square plus 2PQ cos theta. And using that equation, we can find the magnitude of resultant vector R. This is the magnitude of resultant vector R. इस equation से हमें magnitude मिलेगा. कौन सा equation है? R is equal to square root of P square plus Q square plus 2PQ cos theta. Theta is also important here. The angle between these two vectors is also important. If the angle change between vector P and vector Q, then the value of resultant vector R is also changed. So this resultant vector R is not only depend on P and Q, but it's also depend upon the angle between them. Okay, so this is the magnitude of resultant vector R. Now we want to find out direction of resultant vector R. अभी हमें डायरेक्शन फाइंड आउट करनी है. हमें डायरेक्शन किसकी फाइंड करनी है? रिजल्टेंट वेक्टर आर की. डायरेक्शन ऑफ रिजल्टेंट वेक्टर. अभी हमें डायरेक्शन चाहिए. ओके, दिस वेक्टर आर मिक्स एंगल अल्फा विद दिस वेक्टर पी. हम इस रिजल्टेंट वेक्टर आर की डायरेक्शन फाइंड करते हैं इस वेक्टर पी से रिलेटेड. विद रिस्पेक्ट टू पी से हम वेक्टर आर की डायरेक्शन फाइंड करते हैं. ओके, नाउ फॉर दैट वी टेक ट्रायंगल ओ डी C. Which one triangle? O, D, C. And if you see carefully, this is nothing but the angle alpha. For direction, we take tan. So we take tan alpha. Opposite side, which is nothing but the CD, upon adjacent side, which is nothing but the OD. हम अभी यहाँ पे AC को भूल जाते हैं 2 मिनट के लिए. चलो मान लो ये AC को हम भूल गए और हमने कौन सा ट्रायंगल लिया? हमने ट्रायंगल लिया है ODC. Okay, here is vector R mix angle alpha with vector P. Now we take tan alpha. Tan alpha is nothing but the opposite side upon adjacent side. Opposite side is nothing but the DC and adjacent side is nothing but the OD. So we can write at here tan alpha is equal to DC upon OD. But look at here OD. OD is nothing but the OA plus AD. So we are written here tan alpha is equal to DC upon OA plus AD. Okay, if you see carefully toward this triangle ADC. Now look at the triangle ADC. ADC. Okay, which one triangle? ADC. Now there is sine theta. Sine theta. Sine theta is opposite side upon hypotenuse. सो साइन थीटा अगर मैं लेता हूं तो अपोजिट साइड क्या है DC एंड हाइपोटेन्यूज क्या है AC. सो यू कैन राइट इट एज साइन थीटा इज इक्वल टू DC अपॉन AC. सो DC क्या हो जाएगा AC इंटू साइन थीटा. बट वी नो AC हमें पता है AC क्या है आपका Q. सो वी कैन राइट इट एज DC इज इक्वल टू Q इंटू साइन थीटा. लुक एट हियर, ये DC की वैल्यू हमने फाइंड किया. DC की वैल्यू क्या है Q साइन थीटा. एंड इफ यू सी केयरफुली टू दिस OA is nothing but the vector P. We know that. But what about AD? अब इस AD के बारे में देखते हैं. AD is nothing but the adjacent side of this theta. Okay. So triangle ADC, cos theta is nothing but the adjacent side upon hypotenuse. Adjacent side is AD, hypotenuse is AC. So AD is equal to AC into cos theta, where AC is nothing but the Q. So we can write that AD is nothing but the Q cos theta. DC is nothing but the Q sin theta, and this AD is nothing but the Q cos theta, where I put up this value in equation 2. अब ये DC की वैल्यू एंड ये AD की वैल्यू हम इक्वेशन 2 में पुट अप करेंगे तो हमें क्या मिल सकता है. तो हमें मिल सकता है tan अल्फा इज इक्वल टू Q sin थीटा अपॉन P प्लस Q cos theta. Am I right? So we are written at here tan alpha is equal to Q sin theta upon P plus Q cos theta. बट अगर हमें डायरेक्शन चाहिए तो हमें अल्फा के बारे में सोचना होगा. अगर हमें अल्फा चाहिए तो tan r goes that side. So alpha is equal to tan inverse in bracket Q sin theta upon P plus Q cos theta. And this alpha gives the direction of this resultant vector. ये जो अल्फा है ये अल्फा हमें डायरेक्शन बताएगा. किसके डायरेक्शन बताएगा? रिजल्टेंट वेक्टर r की. So here we find, यहां पे हमने क्या फाइंड किया? हमने यहां पे फाइंड आउट किया मैग्नीट्यूड. इस लॉ पैरेललोग्राम में हमने क्या फाइंड आउट किया? In this law parallelogram of vector, where I find out magnitude and direction of this resultant vector r. So what is the law parallelogram of vectors? If two vectors of the same type originating from the same point, tail at the same point, are represented in magnitude and direction, and these two adjacent sides of this parallelogram, then the resultant vector is given magnitude and direction, which is the diagonal of this parallelogram starting from the same point. Then हमने यहाँ पे उस रिजल्टेंट वेक्टर का मैग्नीट्यूड फाइंड किया. क्या है उसका मैग्नीट्यूड? r is equal to square root of p square plus q square plus 2pq cos theta. Then हमने इस रिजल्टेंट वेक्टर की डायरेक्शन फाइंड किया, जो डायरेक्शन हम एंगल यूज करके फाइंड किया, जो क्या है? अल्फा इज इक्वल टू tan इनवर्स in bracket q sin theta upon p plus q cos theta. Now on this law parallelogram we take at here one numericals. इस लॉ पैरेललोग्राम पे हम एक छोटा सा न्यूमेरिकल लेते हैं. We try to learn numericals also simultaneously. Okay, we take at it two vectors. हमने यहाँ पे भी दो वेक्टर्स लिए हैं, f1 and f2, each of magnitude 5 Newton. Here f1 is 5 Newton, f2 is also 5 Newton, and they are inclined each other at 60 degree, means angle between them theta is equal to 60 degree. Now we want to find out at here magnitude and direction of the resultant force. अभी हमें उसका मैग्नीट्यूड एंड डायरेक्शन फाइंड करना है. किसका? रिजल्टेंट फोर्स का. f1 5 न्यूटन, f2 5 न्यूटन, theta is the angle between them is 60 degree. And what is the required value? What do you want to find at here? We want to find out magnitude of resultant force f and direction of resultant force alpha. Okay, whenever we want to find out at a magnitude, then just हमने अभी पढ़ा है, अगर मैं लॉ पैरेललोग्राम लेता हूं यहाँ पे, so using law parallelogram, we can write at here magnitude of resultant force is equal to square root of f1 square plus f2 square plus 2f1 f2 cos theta. Now just we learn this equation. अभी just हमने यहाँ पे पढ़ा है, तो what we can write out at here? F is equal to square root of f1 square plus f2 square plus 2f1 f2 cos theta, which is equal to square root of f1 is 5, hence 5 square plus f2 is also 5 Newton, so 5 square plus 2. f1 is 5 into 5 cos 60. Okay, 5 square is 25, 5 square is 25 plus 2 5s are 10, 10 5s are 50 into cos 60. Cos 60 is nothing but the half. और cos 60 आपका half हो जाता है, तो this 50 upon 2 is 25. So square root of 25 plus 25 plus 25, square root of 75. Square root of 75 is nothing but the 25 3s are 75. We know that 25 3s are 75. So this 25 square root 25 का square root 5, so 5 in square root of 3. We know the value of square root of 3, 1.7 something. So 5 into root 3, if you calculate, then we get force is equal to 8.662 Newton. This is the magnitude of resultant force. F is equal to 8.662 Newton. The magnitude of resultant force we can find out by using law of parallelogram. Why? Because there is an angle between them, which is the theta. They are inclined. Okay, now go ahead. So this is the magnitude. Now we want to find out at a direction. Now direction of resultant force we can find out by using the formula of tan inverse, by using the value of alpha. Alpha is equal to tan inverse in bracket q into sin theta upon p plus q cos theta. ये हमने find out किया है, ये हमें पता है. So in the same manner, what we can write at here? We can write at here alpha is equal to tan inverse in bracket. Instead of q, we put up there f2 sin theta upon, instead of p, we write f1 plus f2 cos theta. If we put up their value, then tan inverse f2 is nothing but the 5 sin theta is 60, sin 60 is nothing but the root 3 by 2 upon f1 is 5 plus f2 is 5 cos 60, theta is 60, cos 60 is nothing but the half. Okay, then what's happened? तो क्या होगा आगे? So tan inverse 5 into root 3 upon 2 upon, अभी हम इसका डिनोमिनेटर सेम करेंगे. So 5 2s are 10 upon 2 plus 5 by 2. Hence we can write at here 10 plus 5 upon 2. हमने बस डिनोमिनेटर सेम किया. ये 2 and 2 is cancel. If the 2 is 2 cancel, then tan inverse 5 root 3 upon 15. 5 3s are 15. 5 3s are 15 means we can write at here tan inverse root 3 upon 3. 3 is nothing but the root 3 into root 3. 1 root 3 is cancelled. So what is remaining there? Tan inverse 1 upon root 3. Tan inverse 1 upon root 3. But we know this is the 1 upon root 3 is nothing but the value of 30 degree. If you take angle 30, then tan 30 is nothing but the 1 upon root 3. So here alpha is nothing but the 30 degree. Alpha is nothing but the angle of resultant force F with F1. So the direction of resultant force is 30 degree with respect to F1. Okay. So this is the direction of resultant force. ये direction है किसका? Resultant force का. So in such manner we can solve the numericals. Using this we can solve the numericals on this law of parallelogram. Now we like to study at here about resolution of vector. अब हमें यहाँ पे next article study करना है resolution of vectors के बारे में. What is resolution? Simple. Resolution is nothing but the process जिसमें हम क्या करते हैं? स्प्लिट करते हैं, सेपरेट करते हैं. किसे? जो भी वेक्टर हमें दिया है, किस में सेपरेट करते हैं? उसके कंपोनेंट में. अगर चलो मान लो मुझे यहाँ पे वेक्टर आर दिया है, तो इस वेक्टर आर को हम सेपरेट कर सकते हैं उसके कंपोनेंट में. और वो जो स्प्लिटिंग होने की जो प्रोसेस है, उस प्रोसेस को हम कहेंगे रिजोल्यूशन ऑफ वेक्टर्स. जो भी वेक्टर होता है उसको अगर हम स्प्लिट करते हैं उसके कंपोनेंट में, तो उसे हम कहेंगे रिजोल्यूशन ऑफ वेक्टर्स. अगर मैं यहां पे वेक्टर आर लेता हूं, तो उसके मैं दो कंपोनेंट लेना चाहता हूं. एक अलोंग एक्स एक्सिस पे जो है वेक्टर आर एक्स, एंड एक अलोंग वाई एक्सिस पे जो होगा वेक्टर आर वाई. अगर मैं वेक्टर आर एक्स एंड वेक्टर आर वाई को कंबाइन करता हूं, तो उसका रिजल्ट हमें वेक्टर आर मिलता है. क्यों? क्योंकि आर एक्स एंड आर वाई ये कंपोनेंट है. किसके कंपोनेंट है? वेक्टर आर के. और जो प्रोसेस है स्प्लिटिंग होने की, किसकी? वेक्टर की. किसमें? उसके कंपोनेंट में. उस प्रोसेस को हम कहते हैं रिजोल्यूशन ऑफ वेक्टर्स. अगर सपोज ये दो कंपोनेंट, चलो मैंने वेक्टर आर के दो कंपोनेंट लिए, अलोंग एक्स एक्सिस पे वेक्टर आर एक्स एंड अलोंग वाई एक्सिस पे वेक्टर आर वाई. इफ सपोज दिस बोथ कंपोनेंट आर परपेंडिकुलर टू ईच अदर, अगर चलो मान लो ये दोनों वेक्टर्स एक दूसरे को अगर परपेंडिकुलर है, if suppose these two vectors, vector rx and vector ry, both are perpendicular to each other, so that time that component is nothing but called a rectangular component. उस component को हम कहते हैं rectangular component. So what is rectangular component? If the component of given vector are mutually perpendicular to each other, then they are called rectangular component of vector. Okay. अगर दो कंपोनेंट एक दूसरे को म्यूचुअली परपेंडिकुलर है, तो उन कंपोनेंट्स को हम कहेंगे रेक्टेंगुलर कंपोनेंट. नाउ लुक एट द डायग्राम. दिस इज वेक्टर आर. ओके. सो दिस वेक्टर आर, from point C. This is OC. OC is nothing but the vector R. From point C, we draw perpendicular on x-axis. It's meet at A point. So here vector O is nothing but the vector Rx. From point C, we draw perpendicular on y-axis, which meet at B. So vector OB is nothing but the vector Ry. Its opposite side is nothing but the AC, which is nothing but also vector Ry. So using law parallelogram, we can say that this vector R is equal to vector Rx plus vector Ry. So vector R is equal to vector Rx plus vector Ry. बट हमें यूनिट वेक्टर का बेनिफिट पता है. क्या होता है यूनिट वेक्टर का बेनिफिट? कि हम मैग्नीट्यूड एंड डायरेक्शन को सेपरेट कर सकते हैं. सो वी नो अलोंग एक्स एक्सिस देयर इज यूनिट वेक्टर इज I. So vector Rx, we can write it here Rx into unit vector I. Rx is the magnitude of this vector Rx plus vector Ry. Ry is the magnitude of vector Ry. And along y-axis there is unit vector is J. So vector R we can write it here Rx into unit vector I plus Ry into unit vector J. अब ये जो वेक्टर R है इसका हमें मैग्नीट्यूड एंड डायरेक्शन फाइंड करना है. दिस हमने लास्ट टाइम फाइंड किया था, मैग्नीट्यूड एंड डायरेक्शन. सो राइट नाउ वी वांट टू फाइंड आउट मैग्नीट्यूड ऑफ दिस वेक्टर R. अभी हमें यहाँ पे मैग्नीट्यूड फाइंड करना है. ओके, दिस थीटा इज द एंगल. नाउ लुक एट द ट्रायंगल OAC. Here cos theta means adjacent upon hypotenuse. So cos theta is nothing but the adjacent Rx upon hypotenuse R. So cos theta is equal to Rx upon R. So you can write it here Rx is equal to R into cos theta. Now Ry is the opposite side of theta. So we can take sin theta. Sin theta is nothing but the opposite side upon hypotenuse. So Ry upon R. So Ry is nothing but the R into sin theta. Look at equation 1, Rx is equal to R cos theta. Look at equation 2, Ry is equal to R sin theta. Now square and add equation 1 and 2. अगर मैं equation 1 and 2 को square करता हूँ and add करता हूँ तो Rx square plus Ry square. देखो मैंने यहाँ पे लिखा है Rx square plus Ry square. जिस हमने इस साइड का स्क्वायर लिया है and add किया, उसी तरीके से यहाँ पे भी क्या होगा? R square cos square theta plus R square sin square theta. So I'm written at here R square cos square theta plus R square sin square theta is equal to Rx square plus Ry square. Here we take common R square. So what is remaining in bracket? Cos square theta plus sin square theta. But we know trigonometric. Cos square theta plus sin square theta is nothing but the 1. 1 into R square is nothing but the R square. So R square is equal to Rx square plus Ry square. This is R square. We want R. So we take square root on both sides. So if we take square root, then we can write that here R is equal to square root of Rx square plus Ry square. अगर मुझे R का मैग्नीट्यूड फाइंड करना है तो हमने इस तरीके से लिया है. अगर हम 2 एक्सिस लेते हैं तो if you take 3 एक्सिस देन, अगर चलो मान लो हम 3 एक्सिस लेते हैं तो वेक्टर R के 3 कंपोनेंट हो जाएंगे. X एक्सिस पे होगा उसका कंपोनेंट वेक्टर Rx, Y एक्सिस पे होगा उसका कंपोनेंट वेक्टर Ry, Z एक्सिस पे होगा कंपोनेंट वेक्टर Rz. We can write this one I into Rx plus J into Ry plus K into Rz. Please never forget this equation. Vector R is equal to I into Rx plus J into Ry plus K into Rz. So that time the magnitude of vector R, इस vector R का magnitude क्या होगा? So we can write that its magnitude is nothing but the square root of Rx square plus Ry square plus Rz square. अगर हम 2 axis लेते हैं तो R is equal to square root of Rx square plus Ry square. And if you take 3 axes, then R is equal to square root of Rx square plus Ry square plus Rz square. And Cartesian coordinate system in 3 dimension, R is equal to square root of Rx square plus Ry square plus Rz square. Means that time this resultant vector R is in space. उस space में है, मतलब वहां पे हम 3 coordinate dimension लेंगे. ठीक है. अगर मुझे यहाँ पे डायरेक्शन फाइंड आउट करनी है, अभी हमें डायरेक्शन फाइंड करनी है. किससे डायरेक्शन फाइंड करनी है? वेक्टर R की. तो डायरेक्शन जब भी हम फाइंड करते हैं तो हम एंगल यूज करते हैं. सो वेक्टर R की हम डायरेक्शन फाइंड आउट करेंगे विद रिस्पेक्ट टू दिस Rx. अगर वेक्टर R की डायरेक्शन हमें Rx से रिलेटेड चाहिए तो हम tan लेंगे, tan थीटा. वी नो tan थीटा opposite side upon adjacent side. So opposite side upon adjacent side is nothing but we can write at here tan theta is nothing but the Ry upon Rx. Opposite side upon adjacent side, Ry upon Rx. So we want theta, tan goes that side. So theta is equal to tan inverse Ry upon Rx. And using that theta, we can find out the direction of this resultant vector. Yes, using that equation we can find out the direction of this resultant vector. ये यूज करके हमने डायरेक्शन फाइंड किया. किसके डायरेक्शन फाइंड किया? रिजल्टेंट वेक्टर की. यहां पे देखो हमने रिजोल्यूशन ऑफ वेक्टर्स में क्या स्टडी किया. इस रिजोल्यूशन वेक्टर्स में हमने स्टडी किया कि हमने दो वेक्टर्स हमने एक वेक्टर लिया है, उसको स्प्लिट अप किया टू वेक्टर्स में, मैग्नीट्यूड एंड डायरेक्शन. Two vectors along x-axis there is a vector rx, along y-axis there is a vector ry. So vector r is equal to vector rx plus ry. Now here the direction, the magnitude of this resultant vector r is nothing but the square root of rx square plus ry square. If you take three axes, square root of rx square plus ry square plus rz square, then direction of this resultant vector is given by equation theta is equal to tan inverse ry upon rx. My dears, we are taking very small numerical on this article. First one, look at here. Show that vector A is equal to unit vector I minus unit vector J upon root 2 is a unit vector. हमें शो करना है, क्या शो करना है कि ये जो वेक्टर A है वो यूनिट वेक्टर है, ये हमें शो करना है. ओके, हमें यूनिट वेक्टर शो करना है. यू नो अबाउट यूनिट वेक्टर, अ वेक्टर हैविंग मैग्नीट्यूड इज 1. जिस वेक्टर का मैग्नीट्यूड क्या होता है? 1 होता है, उसको हम कहते हैं यूनिट वेक्टर. तो चलो हम इस वेक्टर ए का मैग्नीट्यूड फाइंड करते हैं. अगर इसका मैग्नीट्यूड 1 आता है तो हम क्या समझ जाएंगे कि ये कौन सा वेक्टर है? यूनिट वेक्टर. सो अगर हमें मैग्नीट्यूड फाइंड करना है तो हम पहले उसका x कंपोनेंट का स्क्वायर करते हैं प्लस y कंपोनेंट का स्क्वायर करते हैं. नाउ लुक एट दिस इक्वेशन. यूनिट वेक्टर i माइनस यूनिट वेक्टर j अपॉन रूट 2. यूनिट वेक्टर i उसका मैग्नीट्यूड क्या है? यहाँ पे 1 अपॉन रूट 2 उसका स्क्वायर प्लस यूनिट वेक्टर j उसका मैग्नीट्यूड क्या है? यहाँ पे माइनस 1 अपॉन रूट 2, माइनस 1 अपॉन रूट 2 उसका स्क्वायर. So we can write it as square root of in bracket 1 upon root 2 whole square plus in bracket minus 1 upon root 2 whole square. So we can write it here square root of 1 upon 2, square root का square 2 हो जाएगा प्लस माइनस का स्क्वायर भी प्लस होता है 1 upon 2 डिनोमिनेटर से. The numerator की addition 1 plus 1 2, 2 upon 2 is 1. So square root of 1 is nothing but the 1. So if you see carefully, the magnitude of vector A is nothing but the 1 and hence it is called unit vector. Okay, so take small numericals on this article also. This one is last one. Look at here, vector v1, 3i plus 4j plus k, and vector v2 is nothing but the I minus j minus k. Determine magnitude vector v1 plus vector v2. इन दोनों वेक्टर्स को हमें ऐड करना है और हमें उसका मैग्नीट्यूड फाइंड करना है. सो लुक एट हियर, वेक्टर v1 प्लस वेक्टर v2, 3i plus 4j plus k plus vector v2, I minus j minus k. 3i plus I, take common I, so 3 plus 1 I plus 4j plus minus j, common j, 4 minus 1j plus k plus minus k, take common k, so here is 1 minus 1. 3 plus 1 4i plus 4 minus 1 3j plus 1 minus 1 0k means 0. So vector v1 plus vector v2 is nothing but the 4i plus 3j. Now we want to find out its magnitude. अगर हमें उसका मैग्नीट्यूड फाइंड करना होगा तो हमें स्क्वायर रूट लेना पड़ेगा और उसके कंपोनेंट लेने पड़ेंगे, जस्ट लाइक rx square plus ry square. So here square root of rx square is nothing but the 4 square plus ry square is nothing but the 3 square. So square root of 4 square is nothing but the 16 plus 9. 16 plus 9 is 25. So root 25 is nothing but the 5 unit. So this is the numericals on this articles, which is in textbook, जो हमें textbook में दिया है. This is also one numerical. यहाँ पे vector v1 दिया है plus vector v2 और हमें उसका magnitude and direction पूछा था. When you add it, then we get minus 4i plus 2j. And if you take vector r is equal to rxi plus ryj, compare करो, rx होगा minus 4, ry होगा 2. अगर हमें उसका magnitude चाहिए तो square root of minus 4 square plus 2 square is equal to square root of 16 plus 4 is equal to square root of 20. So 20 is nothing but the 4 into 5. 4 5 are 20. So 4 take square root out 2 into root 5. ये हो गया उसका magnitude. And if you take direction, then yeah, we take theta. Theta is equal to tan inverse ry upon rx, which is equal to tan inverse ry. Look at there, ry is 2. Rx is nothing but the minus 4. So we can write at here theta is equal to tan inverse minus 1 upon 2. This is a theta. This angle theta is with respect to x-axis. This all numericals are taken from your textbook. So please see carefully this all articles and textbook numericals. Numericals is very interesting part of your subject. If you practice more and more, you can easily understood it. So my dears, today, before quit this lecture, at one glance see carefully. Today we learn law parallelogram of vector, its statement. Then we are find out the magnitude of vector r. Then we find out at here direction of vector r, resultant vector r. And then we take one numerical on this law parallelogram. We solve it. Then we study at a resolution of vector. Then we study rectangular component of resolution vector. Then we find out magnitude of vector r, direction of vector r, and we take 3 numericals on this resolution of vector. हमने यहाँ पे 3 numericals लिए हैं, हमने solve करने की कोशिश की है, which are very easy. You can easily solve it. I know that you are a very good student. So right now, I like to stop my sharing. I would like to stop my sharing, and I will like to tell a gentle reminder to all of you. Please use SMS, means social, maintain social distancing, use mask, and sanitize your hand. Continuously wash your hand, and please keep your good health and take precautions and prevention what are required for keeping good health. Thank you, my dears. Over to SART team. Thank you, Abhinav sir. Hello, Abhinav sir.
हेलो
हाँ सर, लेक्चर स्टॉप करना. यस,
Yes,
लेक्चर अभी एंड करना है, लीव करना है सर.
yes sir, thanks very much.
Yeah, thank you sir, and thanks for your cooperation sir. Thank you.
Thank you.
Can I leave this meeting?
Yes sir.
Yes, thank you. Thank you, Amol sir.